So we are looking at finishing the examples from section 4.1 on translations, transformations of functions. So the next one that I wanted to look at is number 24, because number 24 now brings up, they changed, we did number 20, where the function was an e to the x function, and that's how we left off when we were in class the other day. So now we're looking at, they changed the function on us to a logarithm, and I thought that that might be troublesome for you, so let's take a look at the logarithm problem. If I have a vertical stretch of 5, now think about where the numbers go in your equation. So if I'm a vertical stretch, where does that 5 go? And just think about it. If I'm reflected around the y-axis, well, what does that do to my equation? And then if I have a horizontal stretch of 3, what does that do to my equation? So I can see just from reading this that I have 3 different things going on in my equation. And my equation starts out, you can call it, well, I think we were doing y equals. You can call it f of x equals, either way. And I know it's a log base 2. I'm going to leave a space. That doesn't change. The log base 2 doesn't change. That's this right here. But then, here's where all these different pieces come in. So I go to the first piece. The first piece is a stretch of 5, vertical stretch of 5. So vertical stretches, if I don't remember, I'm going to go back to my graphic organizer we did yesterday and look at the vertical stretch. Well, that takes the number they give me, in my case of 5, and it goes in front of the function. So if I have that being the case, I'm looking right here, log base 2, the 5 has to go in front of the function. That takes care of my vertical stretch of 5. And then it goes to reflected around the y-axis. All right, well, if it's reflected around the y-axis, again, I'm going to pull back my graphic organizer. And if I'm over here on the left, if I am reflected over the y-axis, then I have a negative sign, but the negative sign goes attached with the x. Okay, so the negative sign is not, it's either out in front, that's over the x-axis, or inside with the x, and that's a y reflection. So that's the one I want. I want the one that's inside with the x. So I'm going to put a parenthesis and I'm going to put a negative right there, inside with the x, not out in front. And then I have a horizontal stretch of 3. Again, back to my graphic organizer. A horizontal stretch, here's my words, horizontal stretch, what do? It's actually 1 over whatever that number is. I have a horizontal stretch of 3. That means I have a 1/3 in that location times my x. So this one's going to be a 1/3 times my x. Let's see if I've got it all in there. I have a vertical stretch of 5. Yep. I have it reflected about the y-axis. That's the negative. I have a horizontal stretch of 3. That's the 1/3 that's here, and I am done. That's my answer to number 24. All right, 27 changes things up. That's the next one. 27, now the directions have changed. They say the graph of the parent function and the transformation of the parent function are given. Write the equation of the transformed function. Well, to me, number 27 is a big old hot mess. So if I'm looking at what is the equation, what am I looking at here? The actual, I'm sure that this somewhere, like you can see one's bold and one's not in the pictures. Well, the one that has been transformed is this one. I'm going to highlight it so you can see it. That's the one that's been transformed. Oh, Deb, that's awesome. Yes, my parent function is 1 over x. Exactly right. And I know that because if I go back and look at, remember the page of notes we did yesterday, the one that looks like it is this guy. Now what's interesting with this one, and I mentioned this when we graphed it, is that this center point, this HK, is at the origin. And that's the piece that changes around and moves. And here's what the equation would look like. A is if it has a vertical stretch of some sort. B is if it has a horizontal scale of some sort. This is a left and right inside of here, and out to the right is going to be your up or down. So this is the way that the equation looks. So the question is, even though this point that's HK is not part of either of the graphs, it's kind of a symmetry thing. It's that point that's directly in the middle of the symmetry of those two graphs. That's what I need to figure out where that is now. So I'm going to go back to number 27 and figure out, well, where's the symmetry point between these two highlighted parts? I'm looking, and I think it's right here. Do you agree? If you were looking at it. Yeah, negative 2, 1. Great. Exactly. So you're seeing the same thing I'm seeing. So this coordinate is negative 2, 1. Now that's going to be important to us because that's telling us how it's shifted. So if the negative 2, that means the x has shifted negative 2. That means it's gone, I'll put it off to the right here. That means it's gone left 2. And the up 1, the 1 tells me it's going up 1. Now the graph doesn't look like it has any, does it have any shifts to this thing? It does actually have a shift in this thing. The function that's Scotty's question, the parent function is not my highlighted one. The highlighted one is how it's moved. So the parent function is this guy over here. So that's really important to us. Now see, if it were not reflected, then my parent, the transformation would be in the same, you know, like if it were in quadrants. The original function is in quadrants 1 and 3. This one's in quadrants 2 and 4-ish. If I were time talking about them. There are no stretches or shrinks. I 100% agree with you. But there is a reflection. There is a reflection in this, and that's what I'm trying to talk about right here. So the original function would be in quadrants 1 and 3. My new function's in quadrants 2 and 4. So has it been flipped over the x-axis or has it been flipped over the y-axis? Tough question. This one's really hard to see, and the guess on the chat is y-axis. I would agree with you. So the y-axis means, and we're going to put it over here, our little thing, y-axis. It's a tough call. I'll tell you that this one's a tough call. This would not be a test question, children. This is not a good, it's a good one for discussion. It's not a great one for a test. Okay, because it's up for interpretation on this, whether it's x's or y's. But you are correct, it is a y. So if I put that all together into my equation, I have y equals. It has no vertical scale differences. So remember in your fraction, it's a in the numerator. So this one's just a 1. It doesn't do anything. But it has been moved. It doesn't have any horizontal scale factors either. Wouldn't the y-axis make x equals negative 2 not an asymptote? This one, the asymptote was at the origin, which is here. Kind of looks like it should be over there. It's right here. This is where the y-axis is. That would have been your original asymptote. Now my asymptote's been moved left 2, so the asymptote really is at negative 2 over here. Which is, let's come back to the asymptote thing in just a second. So far I've got, there is no vertical scale factor, there is no horizontal scale factor, so I don't need to put any numbers in front of my parentheses. In the parentheses goes your left and right stuff. So that's my left 2, x plus 2. Up 1 is going to be outside with a plus 1. But then I have the y-axis flip. Well, the y-axis flip has to be with my x, so it's down here like this. Now let me talk about this. Oh. Yeah, that's fine. So I'm going to do, I can leave it like this. I can distribute out the negative if I wanted to and make it a negative x minus 2. Either way, that's going to be your answer. That one's tricky. That one is a hard one. But there are your 3 pieces. You've got a left 2, up 1, and a reflection over the y-axis. And so that's what your thing would look like. All right. Again, I'm trying to pick the hardest ones so that they make it a little bit easier on you. Number 30 is another goofy one, right? This greatest integer problem. He's the next one that I wanted to look at. So the greatest integer problem In this case, it is the normal stuff. It moves left or right or up or down. There's nothing outside of the greatest integer, so there's no up or down. The minus 3 is inside with the x, and so that's just our normal, as if it were an absolute value or something like that, and x minus 3 moves it right 3. But this time they say, all right, sketch the graph. Well, normally, don't draw this yet, normally this would be your picture. You would have a closed circle at 0. I'm just going to start at the origin because that's the easiest place. And it goes off, and it's an open circle at the next integer. That would have been my first scale for this thing. If I take that and move it right 3, so the closed circle, I'm just going to look at the closed circle, 1, 2, 3. Now my closed circle is here, open circle on the other end, and it's all those points in between. This is where it originally started. This is where it's shifted to. Now it's right 3. So let me take away the original. Now the way the greatest integer function goes, it just jumps up to the next y value, closed circle, goes to the right open circle, jumps to the next value, closed circle on the left, open circle on the right. And you can draw, a bunch of these things. I'll just give you a few. How many do you have to draw? Doesn't really matter. Enough to show that you've got the right 3 thing going on. Okay? So that one, even though it's a goofy graph, that one's pretty easy. All right, I think there's 2 to go, and they're matching. These are now matching problems. And so if I'm looking at, oh, there's my puppy. He's very antsy today. My daughter moved out. She got a house, and she's on her own. So she moved out yesterday, and she and her fiance. Yeah, he's bigger than a puppy. He's a charcoal lab. He's 2. But anyway, she and her fiance have been living with us for the last couple of years, and they just moved out yesterday. And so he's like beside himself. He doesn't know what to do. I'm the only one home, and he's like, "You're no fun." He's used to the kids being around to play. All right. Anyway, there's Levi. He's okay. Trust me. All right. The one that's kind of weird on this is C. C kind of got hole punched out. So just so we are all looking at the same pictures, C has a vertex here at 3, 2, and then it goes like this. If I were to continue it, actually even go smaller than that, to where the hole punch is. It's like that. So that one's it got hole punched off just so you can see it. And the ones that I want to look at, it says match the function without using a graphing calculator, or without, in our case, using Desmos, right? We're going to figure out what these match with. And it's all based off of your right or left, your ups or downs, and you can see they're kind of really similar. The ones that are most complicated are 33 and 36, and so they're the 2 that I want to look at. The first one that I come to, 33 here, can you see what makes that complicated? Because looking at the equation, that doesn't sound very complicated. But there's a problem with it that makes it different than the others we've seen. And it's because if you look at the 3 and the x, they're backwards, right? Usually it should be x minus or x plus. And you can see that in all the rest of them, the x is first. In this one, the x is not. So how do I make it come first? That's what my job is. I'm going to turn it around so that the x comes first. Well, I'm not going to do any algebra with it yet. I'm just going to change their locations. Negative x plus 3, and then a plus 2 on the outside. So I didn't change the value of them, I just changed their locations. And now I want to factor out that negative 1. So I'm going to make it look like this. If I factor out a negative 1, I have the square root of negative 1 parentheses. That would leave me with an x, but it would leave me with a minus 3, and I'll show you why, if you're not catching that, with the plus 2 on the outside. If I distribute this back, negative 1 times x is a negative x, negative 1 times negative 3 is a positive 3, and so this is the same form of what this is, it's just with the negative 1 factored out, but it does change that sign from a positive to a negative. And then for our purposes, we need to figure out what all these numbers have done. I've got the square root graph, okay, that's fine. I've got the square root graph, the minus 3, that's easy to see. That's going to be a right 3. The plus 2, that's easy for us too. That's an up 2. But how about this negative? What did that negative sign do in front? It's in with the x. Negative sign, it's a reflection. So then the question is it a reflection over the x-axis or over the y-axis? And we can see that's going to be a reflection over the y-axis because it's in with the x. So, checking out my graphs. Which one has a right 3 up 2? Oh, this guy. But is it reflected over the y-axis? And we say no. For part B, is it right 3 up 2? It is not. For part C, is it right 3 up 2? Yes. Is it reflected over the y-axis? And it is not. If I go to the next one, this one's not right 3 up 2. Can't do D. E is right 3 up 2. Is it reflected over the y-axis? Is it going the other way? And the answer is yeah, it's going the other way. So this guy E is your number 33. 33 goes with E. It shows all three of those things. All right, then the last one, 36. This one, I thought the 0.5 might be a little bit troublesome, but if you think about that, that's the same thing as 1/2. So I'll put it down here. It's like 1/2 the square root of x minus 3 with a plus 2 at the end. Think about what that does. The 3 again is a right 3. The plus 2 is an up 2. The 1/2 is out in front. It's not directly inside with the x. So that means that this is a vertical switch. So if I do a vertical stretch of 1/2, vertical stretch, and Scotty, I'll get your question. Hang on one second. See if you can figure out which graph that one goes with. And Scotty says, we are comparing it to the original square root graph, which was over here on this page. Here's the original square root graph. If I am taking this thing and I reflect it over the y-axis, that means I'm folding it like symmetry over the y-axis, and it would go this way. So it has to be a graph that goes in the other direction as if it were reflected over the y-axis. So yeah, that's your story for that one. All right, so there's a guess on the table of F, which is a great guess, and unfortunately that's not it. But it's the closest one to it, so you got exactly the right idea. If I have a vertical stretch of 1/2, in other words, there's somebody pulling this up, but it's pulling it up by 1/2, so what's it really doing? You think about a vertical stretch of 1/2, if you're half of what you were, it's actually going to be smaller than what you, like this one's double. This one will be like the F part that you're talking about. See how that one is like it's as if somebody's on top of that pulling it up. You want one where it's pushing it down. Yeah, so this one is going to be, actually, if you're thinking about it, you're right 3 up 2, and you want it to be smaller than the original thing, and C is correct, right? C is the right one. So this one is your 36. But you know what? That's a great mistake to make because it brings up a good discussion. Should it be twice as big or should it be half as small? You know what I mean? So that's what this one comes out to be. That's your 36. So this one went with C. All right, we have like 2 minutes left. Are there any that you have requests from? Any that you are still having trouble with from the list of problems up to 36? All right, so let me go back to our schedule for the day today. By the end of day tomorrow, you are turning in these 1 through 36. So do tomorrow. Also, before class on Friday, you want to watch the 4-2 video because we're going to talk about odd and even functions on Friday when I see you again. Actually, odd and even functions are pretty easy. Once you got the hang of this section, it's not that bad. The beginning of this section, when you're first looking at it, it's pretty complicated. But it should, hopefully, as you do the homework problems and practice problems, it should get a lot easier. And I know that the next section, like I'm saying, section 4-2 is relatively easy. All right, questions, problems, issues? All right, have a great day.